The topic is place value, names for numbers, and reading tables. The objectives for this topic are find the place value of a digit in a whole number, write a whole number in words and in standard form, write a whole number in expanded form, and read tables. We can't talk about place value without talking first about digits. Digits are the single digit numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we use those digits to write numbers. The whole numbers start with 0 and go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on and so forth. I went up that high to differentiate the whole numbers from digits. Digits are just one single digit. Whole numbers can be multiple digits. We go up into 10, 11, go up into 100, 101, go up into 1,000, 1,001. And as we get more and more digits, we keep track of them uh, in terms of their place value. So this here is the place value chart from right to left. It starts with ones and then keeps expanding to add another digit. The tens place value, the hundreds place value. And you can see it's broken up into three place values, and then it's given a different color for the next three place values. The next three ones are thousands, 10,000s, 100,000s, repeating that base place value, tens, hundreds motif. The next three are millions, 10 millions, 100 millions, and then billions, 10 billions, 100 billions. This continues with trillions, quadrillions. Fun fact, zillions is not a number. There is no such thing as a zillion. But let's go ahead and find the place value of the digit 4 in each of these whole numbers. So we go from right to left, ones, tens, hundreds, thousands, 10,000s. In A, the 4 is in the 10,000s place value. From right to left, in B, ones, tens. The 4 is in the tens place value with B. C, from right to left, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. The 4 is in the millions place value in C. So I pointed out these groups of three place values. Each group of three digits is called a period. The period is named after the thing that's not tens or hundreds. So the ones period, the thousands period, the millions period, the billions period. And in order to write or say a whole number in words, we would write or say the number in each period from left to right, followed by the name of the period. The ones period is usually not written, just like it's not said. We don't say 434 ones. We just say 434. The reason I did the second part of this slide first is because this number that it says is written in standard form, I want to be able to say it. So what are our periods? We have the ones period, the thousands period, the millions period, the billions period. So this is 1 billion, and then 83 million, and then 664,000, and then 500. just 500, not 500 ones. So 1,083,664,500. That's written in standard form. Let's take each of these standard form numbers in A, B, and C and write them in words. In other words, we're also going to practice saying them. A is the number 36. Notice that when we write something like 36 or 87 or 84, there's going to be a hyphen, a dash between the tens word and the ones word. So 30-6, and we're going to have 80-7 and 80-4 in B and C. We only put the dashes there, though. In each period, just between the tens and the ones. So B, we would have 487. We don't put any dashes anywhere but the 87. In C, we're not just one period now, we're two periods. We have the thousands period. 32,984. In general, when we see a comma, we say a period. 32,984. The 32 and the 84 are in position to take hyphens. 30-2,000, comma where comma is. 984, 80-4. So when we write it, we want to make sure that we write it in that convention. When we say it, we don't need to say the dashes, but we do need to say the periods. 32,984. Now you might shorthand say that, and you might catch me doing this in this course as well, saying 32,984. That's a way to get your point across, but it is not the proper way to say the number. So again, to write a whole number in standard form, to say a number in standard form, we say the period when we see the comma. So the reverse of that, when we write a number in standard form from spoken form or written form, we want to write the number of each period followed by a comma. So what does that mean? Well, in A, we just have 72. That's one period, so that's the number 72. Nothing interesting about that. In B, we have 906. This is 906, not 960 or 96. 900 tells us the number of hundreds. 6 tells us the number of ones. There are no tens. That's why it wasn't 56 or 36 or 16 even. So a little bit more interesting in B. Now C's the one that's going to explain the definition. 8,000 is its own period because it's separated by a comma. 8,000, we would write the number 8 and then the comma to represent 1,000. And then 654 is 654. So we have 8, 654. 8,654. So we can go both directions, words to numerals, numerals to words. Let's talk a little bit about expanded form. The expanded form of a number shows each digit of the number with its place value. So here we have the number 5,672. Notice how I said that. 5,672. Well, those are the components of the numbers in expanded form. 5,672. And we're adding them together. And that just leaves us with the 5, the 6, the 7, and the 2. So expanded form shows the digit 5 as 5,000 to represent the place value. And then plus the digit 6 is written 600 to represent the place value of hundreds. The digit 7 is written as 70 to represent the place value of 7 tens. And the digit 2 is just written 2 because it's 2 ones, just 2. So how would we write 804,557 in expanded form?
We have an 8 with 1, 2, 3, 4, 5 zeros after it. Or we can think of it as the 8 is in the 100,000 spot. So that's 800,000. And our next digit is 0. So we're not going to add anything just for that. We're going to move on to the 4, which is in the thousands spot. So we're adding to that 4,000. So then we would have our 5. 5 hundreds is 500. And then 5 tens is 50. And then 7. So 800,000 plus 4,000 plus 500 plus 50 plus 7. I want to show another thing that this does. If we were to add these vertically and put in each of our numbers, notice that every column only has one number in it that's not a 0. So it's almost like the number just falls into place.
On to something completely different, reading tables. Tables are often used to organize and display facts that involve numbers. So here's a table. It shows a bunch of countries. It shows gold, silver, bronze, and then some numbers. So these are numbers of medals that certain countries won. The question specifies that they won them during the 2012 Summer Olympic Games. There's also a total column. So this question asks, how many bronze medals did Great Britain win during the 2012 Summer Olympic Games? So the way we read a table is we go down the country column and we find Great Britain. That's right here. And then across the top, gold, silver, bronze, or total. Which one is it asking for? Well, it's asking for how many bronze medals. So we have the bronze column and the Great Britain row. Rows are written left to right, columns are written up and down. And where those two columns intersect, just like if we wanted D3 in Battleship, Great Britain bronze gives us this cell here with 19. So Great Britain won 19 medals during the 2012 Summer Olympic Games. And we can go in reverse order too. What country won 11 gold medals? Well, the gold column, if we find 11, we can go to the country row and see that it would be Germany. So we can go in both directions reading a table. And that's the end of this topic. The topic is adding and subtracting whole numbers and perimeter. The objectives in this topic are add whole numbers, subtract whole numbers, find the perimeter of a polygon, and solve problems by adding or subtracting whole numbers. So adding whole numbers. An electronics store received a shipment of 2 boxes of iPods one day and an additional 4 boxes of iPods the next day. The total shipment in the 2 days can be found by adding 2 and 4. So total represents addition. And the 2 boxes one day and the 4 boxes the next day, if we add those together, we add 2 and 4, that gives us the total shipment in the 2 days. The total would be 6 boxes, and we call the result of an addition problem a sum. 2 and 4 are called addends. The things we're adding together are called addends, and the process of finding the sum is called addition. So similar words, very much related. They do mean different things. When we do addition, we find the sum of the addends. We find the total of the addends. That's the process of addition. We have 16 plus 32. Our rules for doing addition by hand, because there's no calculators allowed in this class, is that we line up the numbers so that they all end in the same spot. And then we look at one column at a time, starting with all the way on the right. What's 6 plus 2? Do it on your fingers if you have to. 6 plus 2, 7, 8. Move to the next column. What's 1 plus 3? 1, 2, 3, 4. I added 3 to the 1, 4. So the answer here would be 48. When we add 2 numbers, our answer is called a sum. So let's find the sum of some other numbers. I don't know, that wasn't that great. We're adding 60 and 628. Again, we make sure that they end in the same spot, not begin in the same spot, end in the same spot. One column at a time. What's 0 plus 8? Well, anything plus 0 is itself, because adding 0 does not change anything. 6 plus 2, 6, 7, 8. Empty spot plus 6. Well, when we see an empty spot, treat it like a 0. 0 plus 6 is itself 6. So 688. Not too bad there. But what if I'm adding 3 numbers? Well, the way we would write it is like this. We wouldn't put 2 plus signs. We just make our column of numbers that are going to be added together, and we put just one single plus sign. Same rules though, one column at a time. So what's the sum of 1, 2, and 3? 1 plus 2 is 3, plus 3 is 6. Next column. 1, 2, and 4. 1 plus 2 is 3, plus 4 is 7. So 76. I'm going to throw a wrench into things now. Nothing major. It's just that I'm going to give you the problem like this. across 45 plus 64. When we see addition written horizontally, don't try to do the work this way. How did we just learn how to do it? Columns. So write it in a column. 5 plus 4 is 9. I'm not hiding with the eraser anymore. One column at a time. 4 plus 6 is 10. This is the first time we've gotten something that's above 9. And since there's nothing that we're interfering with, we're actually able to write the entire 10 in there, just like that. 109 is the answer. Another one. Let's look at 45 plus 790. So you could write this one of two ways. If you keep it in this order, 45 plus, you have to make sure it ends in the same spot. So the 0 would go here, the 9 would go here, the 7 would go there. And add down, throwing another wrench into this one. Let's bring the columns back. High eraser. 5 plus 0 is 5. No issues. Moving on, 4 plus 9, 9, 10, 11, 12, 13. We can fit the 3 in the column, but there's other stuff in this column. We can't just put a 1 here. There's more to add. So what do we do with the 1? Just like those people mumbling math in movies, we are going to carry the 1. So 4 plus 9 is 13. There's the 1, there's the 3. 13. And now we have another number in our next column. We would add the 1 and the 7 to get 8. Okay. Let's do some more work with carrying. Let's look at, and maybe I have a nicer marker somewhere. Let's look at 30,770 plus 490,934. So with addition, not subtraction, just addition, you're able to add the numbers in any order. 2 plus 3 is 5. 3 plus 2 is 5. So if you see this number is bigger than this one in terms of having more digits, this has 6 of them, this has 5 of them. And if you want to write the 490,934 first and the 30,770 second, so that it looks more appealing and you can put the plus sign in. It's nice and compact. You're more than welcome to write it that way. Because it's addition, you don't have to put the first thing first and the second thing second. You can write them either way. So I'm going to tend to start writing them this way when I'm translating from horizontal single line to vertical. And how do we do this? We're going to do it one column at a time. 4 plus 0 is 4. 3 plus 7 is 10. Split it, carry the 1. The 0 goes down here. The 1 goes up here. 1 plus 9 is 10 plus 7
is 17. Put the 7 down here. We're carrying a 1 again. 1 plus 0 is just 1. 9 plus 3 is 12. 9, 10, 11, 12. Put the 2 down, carry the 1, and 1 plus 4 is 5. We put our comma in. Our answer, 521,704. Nine plus 4 plus 1 plus 7 plus 6. So you can go straight down. 9 plus 4 would be 13, plus 1 would be 14, plus 7 would be 21, plus 6 would be 27. But when we have a large group like this, there is a quicker mental way that doesn't have you adding those weird numbers. I don't know about you, but I always used to struggle with my 7 and my 6 and with my 8 and my 7. I just couldn't get it to click in my head quickly enough that 6 plus 7 is 13, that 7 plus 8 is 15. Even now, as I said that, I had to be careful and make sure that that was right. So what's 5 plus 5? That's 10. What's 6 plus 4? That's 10. What's 7 plus 3? That's 10. We tend to recognize things that add to 10 more easily. 9 and 1 is 10. 4 and 6 is 10. And then we have 7 left over. 10 plus 10 is 20, plus 7 is 27. So when we're adding, when it's all addition, just like we don't have to add them in the order they're given, we can switch it around. We could also add around in the list. It's like switching the order to be the way we want it. We can group and add in any order as long as we end up covering all the numbers. Let's do another one like that. Let's add this list of 5, 28, 41, 59, 72, and 15. And we are adding. So you can go straight down the list like I showed originally, but we could also find some groupings of 10. 8 plus 2 is 10. 1 plus 9 is 10. 10 plus 10 is 20, and here's this extra 5. 25, we'll put the 5 down and carry the 2. Number 25 literally gets ripped apart. Four, 5, and 1 make 10. 7 and 2 would be another 9. And 2 would be 11 plus that 10 would be 21. This row with our carried 2, it didn't really have any nice combinations like that. So if you just wanted to go 2 plus 2 is 4, plus 4 is 8, plus 5 is 13, plus 7 is 20, plus 1 is 21. That'll get you there too. What did I say that the answer was called when we added 2 numbers? I said it was a sum. So the first maybe kind of word problem that you're going to encounter in the course is just going to simply say, find the sum of 4,796 and 299.
It's going to be a find the sum of problem. But we know the sum is just what we call the answer when we add. So how do we find the sum? It's just telling us to add 4,796 plus 299. 6 plus 9 is 15. Rip that apart, put down the 5 and carry the 1. 1 plus 9 is 10, plus 9 is 19. Rip that apart, put down the 9, carry the 1. 1 and 7 is 8, plus 2 is 10. Rip it apart, put down the 0, carry the 1. 1 plus 4 is 5. 5,095 would be the answer here. Finding the total of is another way of saying add. What is one number increased by another? I don't know, but you know how you can find out? Add. There are some numbers with special properties when we talk about addition. The sum of 0 and any number is that number. For example, 7 plus 0 is 7, or 0 plus 7 is 7. It doesn't matter if we're adding the 0 second or if we're adding the 0 first. Anything plus 0 is itself. Next, you might notice that we can add any two whole numbers in any order, and the sum is the same. For example, 4 plus 5 is 9, and 5 plus 4 is 9. This special property has its own name, and that name is the commutative property. And it's referred to as the commutative property because commute means move. Your morning commute is when you go from one place to another. We're physically picking up the 4 and the 5, and we are moving them. We are changing their order to get 5 plus 4. But both 4 plus 5 and 5 plus 4 are 9. So we have the fact that changing the order of two addends does not change their sum. Another example would be 2 plus 3 equals 5 and 3 plus 2 equals 5. We can change the order. It does not change the sum. Another property of addition is the associative property. The associative property says that changing the grouping of addends does not change their sum. You could remember this because the people you associate with are your group. For example, if we're adding 3 and 5 and 7, we can group the 5 and the 7 and add that first. 5 plus 7 is 12. And then we could add the 3 on and get 15. If we change the grouping and instead of doing 5 plus 7 first, do 3 plus 5 first, then 3 plus 5 equals 8, and then adding on that 7 also gives us 15. So changing the group does not change the sum. That's only for addition. Subtraction, instead of a sum, we'd be finding a difference. The word for the result of a subtraction problem is difference. And the order matters when finding a difference. For instance, if you have $8 and someone borrows $3, you have $5 left. On the other hand, if you had $3 and someone borrowed $8, you'd be in the whole $5. You'd have negative 5. But we're not talking about the idea of negative numbers yet. If we break down a subtraction problem, just like the things that are added together are called addends, and there's no difference between the first addend and the second addend because we can add addends in any order. Here, we have a special name for the first thing to the left of the minus sign and the second thing to the right of the minus sign. They have two different names because, again, order matters. The minuend comes first, and the subtrahend comes second. Again, the answer for the word for the answer of a subtraction problem is difference. We're going to line things up the same way we did for addition, but instead of plussing, we are going to minus. 6 minus 1, 6 take away 1 would be 5. We're doing the columns same way. 9 minus 6 would be 3. You could use your fingers here too. 6 take away 1 is 5. 9 take away 1, 2, 3, 4, 5, 6 is 3. Subtracting is literally taking away. That's why you might have heard people say take away instead of minus. And as long as the top number in every column is bigger than the bottom number, we don't have to worry about the subtraction equivalent of carrying, which is called borrowing. And that makes sense. If addition has you give something to the next column, I guess you'll see me this way, give something to the next column. Oh, I was right the first time. Next column will show up this way. Nope, this way. And now I'm accidentally hula dancing. So enough of that. 9 minus 7 is 2. 7 minus 5 is 2. 9 minus 4 is 5. Notice 9 bigger than 7, 7 bigger than 5, 9 bigger than 4. We like the subtraction problem when when the numbers on top are bigger than the numbers on the bottom. Let's do a few more. $178 minus 34. 8 minus 4 is 4. 7 minus 3 is 4. 1 minus nothing, because there's nothing there, is still 1. Wrench. I'm going to give it in one single line. Solution. You're just going to write it vertically. That was the only wrench because everything on the top is bigger than what's on the bottom. This is easy. 9 minus 4 is 5. 9 minus 3 is 6. 4 minus 3 is 1. 5 minus nothing is 5. I apologize if you hear the sound of that outside. Someone is doing yard work and there's nothing I can do about it. I'm so sorry. 7888 minus 3553, and we know we don't say those numbers like that. 7,888, 3,553. Write it vertically. And no issues. 8 minus 3 is 5. 8 minus 5 is 3. 8 minus 5 is 3. 7 minus 3 is 4. Now, when we subtract, we have the ability to check by adding. Because if this minus this is that, if we add this back to that, we should get what we started with. So if you don't want to run the risk of this being the wrong answer, you're always able to check by adding. So take the result you got and add back the thing you took away. 3, 5, 5, 3. And if we add, we get 8, 8, 8, 7, which is what we started with. The fact that we checked by adding and got what we started with means that we know before we're even graded 100% we were right. So let's check by adding on this next one as well. 695 minus 395. 5 minus 5 is 0. 9 minus 9 is 0. 6 minus 3 is 3. Are we right? How can we be sure we're right? We can check by adding. So we can take the 300 and we can add back what we took away, the 395. 0 plus 5 is 5, 0 plus 9 is 9, 3 plus 3 is 6, and 695 is what we started with. So we know we are correct. Wrench. 62 minus 43. 2 minus 3 is the number on the top isn't bigger than the one at the bottom anymore. 2 minus 3, that would be a negative number. We can't just use our digits, our 0 through 9. So what we're going to do is we're going to borrow from the 6. We're going to strike down the 6 to a 5. And what are we going to do with this extra 1? We're going to shove it onto the 2. So the 6 goes down to a 5 and the 2 becomes a 12. We lost 110 here and we added a 10 to the 2. 12 minus 3, now that is 9. And 5 minus 4 is 1. I don't know. We should check this by adding because that was something new. Maybe we did it wrong. And when we add our potential answer of 19 plus the 43 that we took away, notice that this problem is going to have carrying because when the subtraction problem has borrowing, the addition problem will have carrying. 9 plus 3 is 12. Split that apart, carry the 1. 1 plus 1 is 2, plus 4 is 6. 62 was the original answer. Let's keep up with the borrowing. And let's look at 90 minus 75. So 0 minus 5 we can't do. The top number is smaller than the bottom. We like when it's bigger minus smaller. So we have to take 1 away from the 9, lowering it to an 8. And that 1 that we took turns that 0 into a 10. The 1 just gets shoved up against it. 10 minus 5 is 5. 8 minus 7 is 1. And we can check by adding 15 plus 75, carry the 1, 9. So that's right. More digits. 717 minus 553. First column, we're okay. 7 minus 3 is 4. Second column, we're not okay. 1 minus 5. So we borrow 1 from over here, lower that 7 to a 6. Shove that 1 we took right up against that 1, so it's 11. 11 minus 5 is 6. And then 6 minus 5 is 1. 164. So the next wrench is going to come in when we borrow from a 0. something that happens in this problem. 800 minus 557. Okay, so 0 minus 7, we can't do it. Normally, we would take 1 away from what's to the left, but it's already a 0. We can't take 1 away from that. So here's how I like to explain it. When we have to borrow, but it's a 0, we jump over all the zeros, and any 0 we jumped over becomes a 9. What we jumped over to is what we borrow from, so the 8 becomes a 7. And since we borrowed that 1, it ends up over here, turning that original 0 into a 10. 10 minus 7 is 3. 9 minus 5 is 4. 7 minus 5 is 2. I'm going to show this again. But next, to kind of try to help you understand why this worked, I'm going to write the same problem, but I'm going to leave myself more room in between the numbers so that I can give you more of a sense of what's happening behind the scenes and why the jump over turn to 9 trick works. We need to borrow to turn this into something. Normally we would borrow from here, but we don't have anything to borrow from. So we need to turn this into something to borrow from, which means we want to turn this into a 10, and we can do that by borrowing from the 8. And now, since this is 10, we can borrow. So we take 1 away from the 10 and it becomes a 9, and that 1 goes here. 10 minus 7 is 3. 9 minus 5 is 4. 7 minus 5 is 2. So the outcome is that this turned into a 10 like we wanted. The thing we jumped over, the 0 that we jumped over, became a 9. We actually borrowed from here, which became a 7, turning this into a 10. So like I said, I'd show it again without all that stuff explained, but now hopefully you see why we do the things we do here. We're borrowing from the 8, it becomes a 7. We jumped over this 0, so it's a 9, and that's a 10. 3, 4, 2. Let's do more with this. Looking for a good one in the homework. 300 minus 282. We need to borrow. We can't borrow from the 0, so we skip over it. We borrow from the 3. Turns the 3 into a 2. This becomes a 10 like we want, and the 0 we jumped over becomes a 9. 10 minus 2 is 8. Yep, I got dogs. Not my dogs. I got dogs on the street barking all day. So annoying. And they stopped. Oh, great. 10 minus 2 is 8. 9 minus 8 is 1. 2 minus 2 is nothing. So we don't write any number there. 0, 1, 8 is not how we write 18. We know how to write 18. 18. Okay. $50,000 minus $25,387. So I wrote it long ways. What's the first thing we do? Write it vertically, write it up and down. We are subtracting. Right off the bat, we need to borrow. We want to turn this into a 10. We got to skip all these zeros. To turn that into a 10, we actually borrow from the 5. That becomes a 4. What do we do with all the zeros that we skipped over? Not the one that we turned into a 10, but the actual 3 that we skipped over, they turn into 9s.
10 minus 7 is 3. 9 minus 8 is 1. 9 minus 3 is 6. 9 minus 5 is 4. 4 minus 2 is 2. Let's check this one by adding. Let's do 24,613 plus 25,387. 3 plus 7 is 0, carry the 1. 1 plus 1 is 2 plus 8. That's 10, carry the 1. 1 plus 6 is 7 plus 3, that's 10, carry the 1. 1 plus 4 is 5, plus 5 is 10, carry the 1. 1 plus 2 is 3, plus 2 is 5, 50,000 is correct. Okay. What about when the zeros aren't all in a row? Does that make the problem easier, harder? Let's find out. 7,030 minus 1,868. Write it vertically. Zero minus 8, we can't do it. We got to borrow. Turn this into a 2. That's a 10 now, though. 10 minus 8 is 2. 2 minus 6, we can't do. We got to borrow. Can't borrow from the 0, so we hop over it. That 0 becomes a 9. The 7 will come down to a 6. And now we've turned our 2 into a 12. Subtraction, right? So we did 10 minus 8 is 2. Now we have 12 minus 6 is 6. 9 minus 8 is 1. And 6 minus 1 is 5. 5,162. Okay, remember when we were doing addition, I said you might see a word problem like the sum of. Well, we got some base level subtraction word problems now. Let's talk about what we would do if it said subtract 2 from 5. Unlike adding, where the numbers can be put in any order, so you don't have to be careful, subtracting cannot be put in any order. You do have to be careful. For instance, 3 minus 2 is 1, but is 2 minus 3 1? No, it's negative 1. Spoiler alert, we're not going to know that until the end of class. The point is, I mean the end of the course, not the end of today. The point is that 2 minus 5 would be different from 5 minus 2. So we need to figure out which one this wants us to do. And the wording is going to tell us. We have to be careful. This is where this math class kind of turns into an English class. If we are subtracting 2 from 5, we need to understand the English language well enough to realize that this is saying we are starting with 5 and we are subtracting 2 from the 5. So we're starting with the 5, and from 5, we subtract 2. This would be 3. And just like a sum is the answer of an addition problem, the answer to a subtraction problem is called a difference. So when you subtract 2 from 5, you get a difference of 3. Speaking of the word difference, just like a problem would say find the sum of, now we're going to say find the difference of 30 and 21. Subtracting has to be in the specific order. So you have to understand what it's asking. This one, we actually keep them in the order they're given. When we see difference of blank and blank, that is a subtraction and you keep it in the order that it was given. So the difference of 30 and 21 is 30 minus 21. Another way of asking this same problem would be, what is 21 subtracted from 30? 30 minus 21, which will set up vertically. 0 minus 1. Well, notice I put a 9 right away. 30 minus 21, that'll come to you. And if we want to show the work we're doing here and keep it consistent with what we did before, 0 minus 1 we can't do. So we borrow from the 3, turning it into a 2. Now this 0 is a 10. 10 minus 1 is 9. 2 minus 2 is nothing. So the difference is 9. Another weird way of seeing a subtraction problem. Find 106 less 53. This does not say find the number that is 106 less than 53, which would be some negative number. 106 less 53 means we start with 106 and we make it less 53. In other words, what's this number if there were 53 less? If we subtracted 53. So less is another one like the difference of blank and blank, where we keep them in the order given. 6 minus 3 is 3. 0 minus 5, just bring that 1 over. 10 minus 5 is 5. So it is 53. Check by adding. 53 plus 53, 106, we're good. What's the key word in this one? Find 44 subtracted from 100. If you had to pick a word that was the most important word here, you might want to say subtracted. But if there was a different word that's the most important word here, not a lot of words left. From. Subtracting from 100 means we have started with 100, and from that we are subtracting 44.
Let's move on to find the perimeter of a polygon. A polygon is any flat figure formed by line segments connected at their ends. So if you draw a bunch of lines and they connect in the end, you have a polygon. So they can be nice figures like this rectangle or this square or this triangle, or they can be weird looking like the one we're going to see on the next slide. But no matter what the polygon looks like, the perimeter is the distance around. In other words, it's the sum of the lengths of its sides. Pick a starting point, walk around it. When you get back to where you started, you stop. Walk around the perimeter of a building means walk around the building. The distance you've walked is the perimeter. The sum of what you walked, the sum of the sides. So here's that weird looking figure I promised. That is a polygon. It's a bunch of lines that connect. Find the perimeter, pick a starting point and walk around it. I'm going to pick that point at the top. 5 plus 4 plus 3 plus 6 plus 8. I'm going to add the sides. You didn't have to do 5 plus 4 plus 3 plus 6 plus 8. Maybe you went the other direction. 8 plus 6 plus 3 plus 4 plus 5. That's fine, as long as you stop before getting that 8 again. Or maybe you picked a different point. Maybe you picked the point on the left instead of the point at the top, and then you went 4 plus 3 plus 6 plus 8 plus 5. That's fine. Or maybe you picked the point on the left and then you went clockwise. 5 plus 8 plus 6 plus 3 plus 4. No matter where you start, as long as you end in the same spot, and whether you go left or whether you go right, clockwise or counterclockwise. Well, left would be counterclockwise, right would be clockwise. That's only if you're thinking about it the same way I am. Sorry. I drifted off my point. My point is that you're going to get 26 inches no matter what. So perimeter is a type of word problem that requires addition. Some other problems that require addition might use keywords or phrases such as added to, plus, increased by, more than, total, or sum. For instance, 2 added to 3 is 2 plus 3. 5 plus 93 is 5 plus 93. 13 increased by 5 is 13 plus 5. 9 more than 30, 9 plus 30. The total of 3 and 5, 3 plus 5. The sum of 391 and 3, 391 plus 3. For some of those, I'd make the argument that the English language would have us add them in the other order. But the beautiful thing about addition is it doesn't matter what order you add in. But for subtraction, you've got to get a lot more specific. Some keywords that we might see that indicate that we have a subtraction word problem are obviously subtract would mean subtraction. But we would need to keep an eye out for difference, less, less than, take away, decreased by, and subtracted from. An example of each. Subtract 2 from 7 means we're starting from 7 and subtracting 2 from it. So subtract 2 from 7 would be 7 minus 2, not 2 minus 7. For difference, the difference of 13 and 1 just follow the same order that it's given in. The difference of this and this is this minus this, 13 minus 1. 19 less 5. Well, if you started as 19 and now you're less 5, you're 19 minus 5. Less than 3 less than 24. You'd start with 24 and you'd subtract 3, 24 minus 3. But 16 take away 4, you're starting with 16 and you subtract 4, 16 minus 4. 8 decreased by 7, you're starting with 8 and you're decreasing it by 7, you're subtracting 7, 8 minus 7. But 6 subtracted from 14, you're starting with 14 and you're subtracting 6 from that. 14 minus 6. Right now, when we don't know or consider negative numbers, it's pretty easy to just put them in the order that gives you a positive result. But you can't do that once we allow for negatives. So you do have to learn what these mean. An example involving adding. The state of Hawaii has 1,851 miles of urban highways and 2,291 miles of rural highways. By the way, notice these are numbers in the thousands, but there's no comma. When it's just a 4-digit number, the comma is optional. But if there were 10,000 or more, the comma would have to be there. But 9,999 and less, optional comma. Anyway, that's not this lesson. Find the total highway mileage in Hawaii. That's this lesson. So the total highways would be the urban plus the rural. So we add the numbers. Total indicates addition. 1,851 plus 2,291. We'd write them vertically. We'd add. We get 4,142 miles. Feel free to pause and practice addition. Make sure you get that number. Dilys King is reading a 503-page book. If she has just finished reading page 239, how many more pages must she finish to read the book? So what does she have? Well, total there's 503, but she's less 239. She's done 239 of them already. We can subtract those away from the 503. So this sets up subtraction, 503 minus 239. Set it up vertically. Try it on your own if you want. Make sure that the answer you get is 264. As years pass, the number of endangered species per country increases. In the following graph, each bar represents a country, and the height of each bar represents the number of endangered species identified in that country. Let's look at this graph on the next slide. Which country shown, not county, which country shown had fewest threatened amphibians? Which bar is the smallest? That would be China at 92. Don't just assume because it's on the right that it's the smallest. I actually looked at every number and made sure that 92 was the smallest number there. But with 92 threatened amphibians, China had the fewest. Another question concerning this same data. Find the total number of threatened amphibians for Brazil, Peru, and China. So now that we've reviewed how to read the graph, now we have something that involves what we've done in this lesson. Finding the total number is adding. So we'd be adding Brazil, Peru, and China. Brazil is 116, plus Peru is 96, plus China is 92. We add those together, we get 304. And that is it for this topic.